Forward. Deep learning has come a really long way. From the birth of the idea to understand human mind and the concept of associationism, how we perceive things and how relationships of objects and views influence our thinking and doing, to the modeling of associationism which started in the 1870s when Alexander Bain introduced the first concept of artificial neural networks by grouping the neurons. Fast forward it to today 2018 and we see how deep learning has dramatically improved and is in all forms of life, from object detection, speech recognition, machine translation, autonomous vehicles, face detection and the use of face detection from mundane tasks such as unlocking your iPhone X to doing more profound tasks such as crime detection and prevention. Convolutional neural networks and recurrent neural networks are shining brightly as they continue to help solve the world problems in literally all industry areas such as automotive and transportation, healthcare and medicine, retail to name a few. Great progress is being made in these areas, and just metrics like these say enough about the palpability of the deep learning industry. Number of computer science academic papers have soared to almost 10x since 1996. VCs are investing 6x more in AI startups since 2000. There are 14x more active AI startups since 2000. AI-related jobs market is hiring 5x more since 2013, and deep learning is the most sought-after skill in 2018. 84% of enterprises believe investing in AI will give them a great competitive edge. And finally, the error rate of image classification has dropped from 28% in 2012 to 2.5% in 2017, and it is going down all the time. Still, the research community is not satisfied. We are pushing boundaries, and I am moving ahead with my peers to develop models around the bright and shiny capsule networks and give deep learning a huge edge. I am not the only one in this battle. It is with great pleasure I put this forward for Naveen, a respected professional in the deep learning community I have come to know so well. His book is coming just at the right moment. The industry as well as learners are in need of practical means to strengthen their knowledge in deep learning and apply in their job. I am convinced that Naveen's book will give the learners what they need. TensorFlow is increasingly becoming the market leader, and Keras 2 is being adopted by professionals to solve difficult problems in computer vision and NLP, natural language processing. There is no single company on this planet who isn't investing in these two application areas. I look forward to this book being published and will be the first in line to get it, and my advice to you is, you should too.
Chapter 1. Basics of TensorFlow.
This chapter covers the basics of TensorFlow, the deep learning framework. Deep learning does a wonderful job in pattern recognition, especially in the context of images, sound, speech, language, and time series data. With the help of deep learning, you can classify, predict, cluster, and extract features. Fortunately, in November 2015, Google released TensorFlow, which has been used in most of Google's products, such as Google Search, spam detection, speech recognition, Google Assistant, Google Now, and Google Photos. Explaining the basic components of TensorFlow is the aim of this chapter. TensorFlow has a unique ability to perform partial subgraph computation so as to allow distributed training with the help of partitioning the neural networks. In other words, TensorFlow allows model parallelism and data parallelism. TensorFlow provides multiple APIs. The lowest level API, TensorFlow Core, provides you with complete programming control. Note the following important points regarding TensorFlow. Its graph is a description of computations. Its graph has nodes that are operations. It executes computations in a given context of a session. A graph must be launched in a session for ANY https://www.tensorflow.org/install/. Chapter. Basics of TensorFlow. A session places the graph operations onto devices such as the CPU and GPU. A session provides methods to execute the graph operations. For installation, please go to https://www.tensorflow.org/install/. I will discuss the following topics: tensors, computational graph and session, constants, placeholders and variables, creating tensors, working on matrices, activation functions, creating tensors, loss functions, optimizers, metrics, tensors. Before you jump into the TensorFlow library, let's get comfortable with the basic unit of data in TensorFlow. A tensor is a mathematical object and a generalization of scalars, vectors, and matrices. A tensor can be represented as a multidimensional array. A tensor of zero-rank order is nothing but a scalet. A vector array is a tensor of rank 1.